Okay, assalamu alaikum. I hope this video sums up the lesson we took in Thursday, the formulas, the concepts, the skills, etc. So let's start first with identifying our first skill, which is differentiating between left sum and right sum. Okay, and let's first start by drawing a graph. Okay, and let us draw a curve. And now let's draw a rectangle. Okay, actually, let's draw two. So when the curve first hits the left side, so this is the left side of the rectangle, right? So when the curve hits the left side of the rectangle first, we call this left sum. But in case it hits it first on the right side, we call this right sum. Okay? This is for the first skill. Our second skill is identifying and differentiating between oversum and overestimate and underestimate. So an overestimate, which is usually right sum, is basically, so let's draw a right sum. We will see that there is some extra space that is above the curve, as we can see here. Okay, so this is part of the rectangle that is above the curve. We call this overestimate. Okay, but in case it's under, which is usually left sum, so let's draw it like this. It will be and then let's just extend this a bit. It will be like this. So you can see here some space that is under the curve, and we call this underestimate. Okay, now let's start solving the questions. So let's draw a graph, and they ask us to draw the left sum and right sum of each question. Okay, so and the curve is from 2 here. It goes like this. The n equals 4. The interval is from 0 to 8. So let us draw. This will be 0 and this will be 8. And finally, let's identify first what is delta t. So delta t is equal to, and the equation, if you remember it, it is b minus a divided by n. And we have all of these givens. So this is a and this is b. So b is 8. Let's write delta t equals 8 minus a, which is 0, divided by n, which is, as we see here, 4. So 4 minus 0 is still, 8 minus 0 is obviously 8, but then 8 divided by 4 will equal 2. Okay, so delta t is equal to 2. Now, what does delta t, what is even delta t? Or sometimes they write in books delta x. What is it equal to, or what does it mean? Delta t is basically the width of rectangle. Okay, so we should have here 4 rectangles because n is 4, and each is 2, the width of each rectangle is 2. So this is 0, there will be another rectangle here, another rectangle here, and another rectangle here, and finally at a 2. So let's first draw it. Let's choose left sum, for example. So left sum, it will start from here. We can see that the curve touches the left side first of the rectangle. So we go to 2 here, and then it goes down. And then again, we draw another rectangle that goes to 4. And then we draw another rectangle that goes to 8, or say 6. And finally, another rectangle that goes to 8. Okay, so we can identify here, we can see that this is, since it's left sum, it will be, as we said, underestimate. And we've proved this by graphing. We can see here some space under the curve. So n is 4, and this will be f of 0. this will be f of 2, this will be f of 4, and this will be f of 6. Now, what is f of 1, 2, 6, 7? These will be plugged into our equation that was given. Sorry, I did not write it. It is x plus 2. Okay, so let us sub in, for example, 0 plus 2 under the root, which will give us root of 2, and this is equal to 1.4. So we will write here 1.4 plus then f of 2, f of 2, f of 4, f of 6, and then we will multiply them all by what? By the width, which is 2. Because remember, this is how tall the length is, f of 0 and f of 2, and the width is, as we said, 2, 2, 2, 2. Okay? That being said, now let's rewrite the whole thing again. Actually, let's just delete some of it, and we will keep some. This time it will be right sum. As we said, if it's right sum, it means that it will be overestimate. And let's draw a curve from 2 like this. Finally, let's start drawing the rectangles. This will be 0, this will be 8, this is our interval. 2, 4, 6. And let's just change the pen for better accuracy. So we'll see that it touches the rectangle first from the right side. Okay, again, we draw the point on the curve, and it goes back to the first or the previous rectangle. Here, 6, go to the curve, then go back to the previous line you draw, and then it goes down. Finally, our fourth rectangle will be at 8, and it will be like this. Okay. Now we can see that we've proven this is right sum, which is also overestimate. And how do we know it's overestimate? We can see there's area above or over the curve. So if it's under the curve, there's area under the curve, it's underestimate. If there's area over the curve, it is overestimate. Okay, now this will be f of 2, this will be f of 4, this will be f of 6, and this will be f of 8. Remember, we plug it in the original equation, and we will get, also we'll times it by 2, which is the width. So we'll get f of 2 plus f of 4 plus f of 6 plus f of 8. Now remember, the difference between the left sum and right sum in the equation is that in the left sum, we started from f of 0 and then got to f of 6. But in the right sum, we started from f of 2 because, like as we can see here, this is the first point at 2. It did not start at 0 like the left sum, which means that it will start from f of 2 till f of 8. And we sub in each of them in the equation, which is x plus 2 under the square root. Then we times it by 2, which will get us the answer. Moving on to the second question. Figure 4.14, which is this one, shows the velocity of an object, and they gave us the interval 0 to 8. So, well, they've plotted the graph for us. We don't have to draw it. Calculate the following estimates of the distance the object travels between t equals 0 and t equals 8. As we said, this will be A, this will be B. And indicate whether each is an upper or lower, it's not underestimate, it's lower estimate of the distance traveled. Same idea. Okay, so they want us to solve it twice. One time we will use the left sum, the other time we will use the right sum, and this is why we have the same question repeated twice, is that we can solve it both ways. So as we said, if we have two rectangles, n is equal to, so let's write 8 minus 0 over 2, which means that it will give us 4, which is what? Delta t, the width. Okay, so we'll have two rectangles, and well, we have, yeah, we can just separate this here. Okay, so this is the middle where we can draw two rectangles. Let's start with right. Okay, so as I said, draw it on the curve, then let it go back again here on the curve, and then let it go back. And this, oops, we can see this, that the width of this is 4, the width of this rectangle is also 4, which what we can confirm it via our equation, aka delta t. Okay, again, we can use the same thing here. It becomes, we'll start from 0, yes, then we will go to f of, or sorry, 4, and then again we will go to f of, or sorry, the point 8. So this is left sum, and we can see it's lower estimate because there's a lot of area under the curve, and this is overestimate because there's a lot of area over the curve. Okay, now what we usually do is we have an equation like the one we had in the previous question here, but in this case we will just count it from the rectangles and then times it by the width. Then we move on to question number 5. Figure 5.5 shows the velocity v of an object in tears TRS per second. I'm guessing this is a unit. Estimate the total distance the object traveled between t equals 0 and t equals 6. So I'm pretty sure that n is in this case 6. I don't know why they haven't mentioned it, but it becomes delta t is equal to b minus a over n. This is a, this is b, so delta t is equal to 6 minus 0 over 6, which is essentially 6 over 6, aka 1. So our width will be 1, and we will have 6 rectangles. In this case, they didn't tell us whether they want it in as left sum or right sum, so we can decide, or we can do both. So let's use right sum. I like to start with right sum. So let's go to 1 here and go to the curve, and let's draw the rectangle. Again with 2 here, goes back to the previous line, and then draw the rectangle. 3, 4, 5, and 6. So let's start real quick. Again, right sum equals overestimate. Okay. We can see this is the extra area. So let's get the area under the curve. How do we get it? Well, let's get the width and let's get the length. So width, we already got it, which is 1. So we will just write here 1 times all of the lengths summed up, but it doesn't matter since it's 1, so we will just add what? We will just add the length. So we can see here that this is 15 probably, so 15 plus. The reason we times the length by width is that because this is the area of the rectangle. So area of rectangle is equal to length times width. Okay, and if we get the area of all of these rectangles, we'll get an overestimate of the actual value. And in case we get the left sum, it will be lower estimate of the actual value. You can then add them up and then divide them by 2, but that's to get a more accurate answer. But we have a calculator that gives you the exact answer, so you don't need to go through that whole process. So let's continue. So this is 15, this is 20, this is actually never mind. Yeah, this will be 15, this will be 20, this will be 35, and this will be wait, I can see. Okay, let me just move all of the things. Okay, so this will be 20, and this will be 25, this will be 30, and this will be 35, and the last one will probably be somewhere around 37. So we have here 15 plus 20 plus 25 plus 30 plus 35 plus 37. Okay, this is times the width, which is 1. So, but as we said, it's 1 and it's not going to change the value. So if we add them up, this is the overestimate of the actual value. So if we get, for example, 200, then the actual value may be, let's say, 175. And we can get the left sum, and we may get like 150. Okay, and the actual value is 175. But as I said, this is lower estimate and this is overestimate, just to get an approximate value of the actual answer. That being said, I believe this sums the lesson up. Thank you.